Okay, so this week your maths unit is unit 21, and I'm going to go through the answers with you now to make sure that you have got them right. Okay, so let's look at number 1. 7 plus what equals 10? What I usually do in this situation, it actually means that you can say 10 minus 7 equals what? You can move it around like that if the numbers are bigger. This one, you can do that as well, or it's just as easy to count on from 7 until you get 10. Okay, so the answer is 3. All right, number 2, add 7 to 11. So in this situation, I would start with the bigger number and then add on. So the answer is 18. Number 3, subtract 10 from 50. Now remembering, whenever we subtract, we need to start with the bigger number. Okay, so when it says subtract 10 from 50, okay, so we're taking the 10 from the 50, okay, and that will give us 40, okay. 24 minus 4, okay, count backwards, is 20. The difference between, now remember that difference between means minus, okay? So we need to do 47 minus 5, okay? So just keep an eye on whenever you see the words difference between, okay? That means using subtraction. Okay, number 6, 5 lots of 3. Now the words lots of means times, okay? So we're going to go 5 times 3 equals, you should all know that one off straight away off the top of your head. The answer is 15. Well done. 7 times 6. Okay, so our times tables are so important to learn, okay, because as you get older, you will keep getting stuck if we don't know our times tables. So especially while you're away, at home, it is a good idea to focus on really learning your times tables well. So 7 times 6 is 42. Well done. 8 times 4 is, yep, so you might not know that one off the top of your head. A way we could do it is, if we know 8 times 2, okay, which is 16, and then we're going to times 2 again, okay, which equals, right, 32. Okay, so whenever it's times by 4, we can say times 2, then times 2 again, okay? All right, 25 cents plus 5 cents plus what equals 40? So in this situation, what I would usually do is I add the 25 and the 5 together, which gives us 30 cents, okay? And what else needs to be added on to 30 cents to give us 40 cents? That's right, 10 cents. Okay, so just break it up like that. It helps us to solve it. Okay, number 10. How many hundreds in 224? How many hundreds? Okay, so we're looking at the correct column, the place value of hundreds. So how many hundreds? There are this one. Okay, we know that that's the hundreds column because this one is the ones. Okay, so the one on the right is always the ones, then the next one is the tens. Okay, so usually it has 2 digits after it, and that's when we know that it is the hundreds. Okay, so how many hundreds are there? There are 2. Correct, so the answer is 2. 11. 53 plus 6. Okay, that one's fairly straightforward. Just really add the 3 and the 6. Okay, 59. Okay. Okay, the product of 5 and 8. Now that's a word you might not have known before, but product means times. Well done if you knew that. That's great. So the product has to do with multiplication, but it actually means what the answer is at the end. So 8 times 5 equals 40. Now, this is the product. This number at the end here is called the product, okay? So it's whenever you times two numbers together, the answer is called the product, okay? And number 13, you guys should be able to do this one. The sum of 8 and 5. What does sum mean? Sum. That's right, it's addition, okay? So 8 plus 5 equals... Yeah, that's right. With this one, we can start with the bigger number, or, yep, whichever way, you should know it straight away. So it's 13. Very good. Now, days in August. This one's an interesting one. How do we remember our days? Okay, so just remember you can have your knuckles. That's a good way to remember what days there are. So if you put your two hands in fists, and the knuckle is 31 days, and between it is 30. So start from the left. January, February, March, April, May, June, July. July has 31, and then it jumps over to the other hand. August has 31 as well. Okay, so we've got to remember that June, July, August. So July and August both have 31 days. Okay, 30 days has September, April, June, and November. All the rest have 31. Okay, how many pairs of socks could be made from 22 socks? Okay, so 22 individual socks, and if we put them into pairs, that's putting them into groups of 2. So then how many pairs would we have? How many groups of 2? Yeah, that's right. So you divide it by the 2. That's it. So the answer is 11. Very good. All right, let's go up the top to set number 2. So this is subtracting. All right, this is just straight subtracting. So you should be fine with this, to be honest. So number 1, 6 minus 3 is 3. 4 minus 4 is 0. 7 minus 3 is 4. So that is your answer there. 7 minus 6 is 1. 4 minus 3 is 1. 6 minus 3 is 3. 8 minus 4 is 4. 3 minus 1 is 2. 7 minus 5 is 2. 9 minus 8 is 1. 5 minus 2 is 3. 4 minus 2 is 2. 7 minus 6 is 1. 6 minus 2 is 4. 5 minus 3 is 2. 8 minus 5 is 3. 5 minus 2 is 3. And 9 minus 6 is 3. Number 7. 6 minus 6 is 0. 8 minus 6 is 2. 7 minus 1 is 6. Number 8 is 7 minus 7 is 0. 9 minus 7 is 2. 8 minus 1 is 7. 9 minus 4 is 5. 8 minus 4 is 4. 8 minus 3 is 5. Okay, so there our subtraction without trading. You should have been able to get that no problem. If you did not get those correct, it is good for you to be revising your subtraction, because they are fairly straightforward subtractions there. Okay, who spent more money when they went shopping? Was it Liz? So Liz had $90 and came home with 5. Oh, no, 35. It's good to make sure you're reading it correctly. Mark had $70 and came home with $34. More money was spent by. Okay, so how much did they spend? Who spent more? So the question is not asking who had the most. Okay, if it asked who had the most, it would be Lisa because she had 90, but that's not the question. The question is saying who spent more. So I need to figure out how much each of them spent. So Lisa had 90 and she came home with 35. So I need to find out how much she spent. She spent whatever was between that. Okay, so I'm going to go 90 minus 35 equals, all right, and to sort that out in my mind, how I work that out is I go 35, I'm going to add 5 to get to 40, and then from 40 to 90 I know is 50. So the answer is 55. So $55 she spent, and Mark with 70 and 34, so I'm going to go 70 minus 34 equals, I'm going to figure out the same way, 34 to 40 is 6. Okay, so I have 6 in my ones column, and then I'm at 40 to 70. Okay, so that's 30. So spent 36. So now looking at the question, who spent more? Liz with 55 or Mark with 36? That's right, it was Liz. More money was spent by Liz. Number 11, what was the total amount spent by the children? Total amount. That usually means that we add them together. Okay, so what was the total amount spent? So I need to add the ones, how much they spent together. So 55 plus 36. 55 plus 36. 11. 5 plus 3 is 8, plus 1 is 9. $91. $91 was spent together. All right, very good. And geometry down here. Draw a line to match the prisms to their sets of faces. So we've got some prisms here. The picture's over on the right. And we need to match them to the faces. Now, straight away, I recognize this one, the cube. And the cube is a bit special because I know that it all has the same shape side. And I know that each of the sides of the cube, the 2D faces of them, the 2D shape is a square, and there's 6 of those sides. So I'm going to draw a line to that one. Very good. Okay, now let's look at this one next. Let's look at this one next. Now this one is a prism. Okay, they're both prisms, the next two. So this one and this one are both prisms. We know that because there's no apex. But we're going to focus on this one first. So because it's a prism, it does have rectangles on the edges. So on the faces. So the top one, this side one, and then remember that there's one at the bottom that we can't see, and then at the back. Okay, that looks like a whole lot of scribble, but we've got to see the faces that we can't see. So we need to remember that they're there. Okay, so there were 4. So there's 4 of those rectangle faces. Okay, just picture the other sides as well. So we've got 4 rectangle faces, and we've also got 2 shapes on the end, which from this direction look like squares to me. So let's have a look. 4 rectangles and 2 squares. Here we go. That is our square-based prism. Very good. And now this one here we have is a prism as well. So we've got the rectangles on each face. Okay, and we've got 1, 2, 3 ones that we can't see the bottom one because it's on the floor, and we can't see the other side because it's facing the other way, but we need to remember it's there. So there's 3 rectangle faces there, and we've got the shape that is the same on either end. So we've got the triangle here, so there will be a triangle on the other side. So we've got 2 triangles and 3 rectangles. So that looks like that one. Fabulous. Good work. So that is the first page. And I'm going to go over to the second page because we need to make sure that we're doing both pages. Okay, it is very important. So let's have a look. Set number 3, comparing fractions. Okay, so write the fraction for each shaded shape. So here. Now, the 8 at the bottom of a fraction shows us how many parts there are in something. So we can see here that there are 8. There's 1, 2, 3, 4, 5, 6, 7, 8 parts. Now the part that's on top, this number that's called the numerator, shows us which part is shaded. Okay, each shaded part. So we've got to count the shaded parts. 1, 2, 3, 4, 5, 6, 7. Okay, so we're going to put a 7 there. And that is the answer for that one. Number 2, can you try to do this by yourself? Yep, so it's got 8 sides, 8 parts, like the other question. And this one is telling us how many shaded parts are there. Yeah, you just count. 1. Easy. 1. 1/8. Good job. Number 3. We've got 5 parts here. So this, imagine it's a block of chocolate, is split up into 5 parts. And how many of those parts are shaded? Count with me. Good. 4 is the answer. So 4/5 of that block of chocolate is shaded. Number 4 is, how many is this one? Easy. 2. 2/5. Well done. All right, number 5. This looks a bit different, but as long as each part is even, it works. So this part has 8, again, 8 even parts. And how many of them are shaded? 1, 2, 3, 4, 5, 6. So 6 is our answer. 6/8 is our answer. Very good. And over here, this one's divided up into 4 parts, and there are 3 of them shaded. So we're going to write 3/4. All right. Is 3/4 larger than 3/8? Is 3/4 larger than 3/8? Okay, so let's have a look at that one here. If we look at the 3/4 here, this is an example of 3/4. If I was to, let's just imagine, split this up into 8 parts, 8 equal parts. You've got 1, 2, 3, 4, 5, 6, 7, 8 here, and you're only to shade 3 of them. It would only be this much shaded. So the 3/4 would shade, everything that's shaded would shade this much, the 3/4 would, and the 3/8 would just shade this part. Okay, so then that means which one's larger? The 3/4. Very good. But another way to know that is also, if the number on top is the same, if the number on the bottom has a higher value, so if the number is bigger, it actually means that it's smaller. The whole fraction is the smaller one. Okay, so it's a bit of a trick, but whenever the denominator, the number on the bottom, is higher, it means that the section is smaller. So see here, if we look here, we've got the 8s here. Each part is smaller than this part, okay, even though this is 4. So if you've got a smaller denominator, the section is actually bigger, whereas the bigger the denominator, the smaller the section or the part is. Okay, very good. So the answer is 3/4 there. What can you say about 6/8 and 3/4? What can you say about that? Well, I wonder who got this one right, but what you can say about them is if you try to make 6/8 using smaller numbers, if you want to simplify it, we can actually simplify it to actually equal 3/4. It actually is 3/4. So let's have a look at this question and this question. The fraction is actually different, 6/8 and 3/4. Okay, the fraction is different, but look, ignore all the little lines to show the different parts, but just look at the shaded parts. It's actually the same amount. So this is the same as this. These fractions are actually equal to each other. 6/8 and 3/4. So we can also know that because if we want to simplify 6/8, we can divide it by 2, which gives us the 3. We can also divide it by 4, divided by 2. What I do to the bottom, I must do to the top, so I do them both the same, and that actually gives me 3/4. Some of you have not heard about simplifying before, but those of you that have will understand that. Okay, let's go up to set 4. All right, let's go. What times 15 is 30? Okay, well, we know that if we add, the 15 times 2 is 30. If we add 15 plus 15, it equals 30. So that means that 15 times 2 is 30. Good. Tom spent 5 cents and 15 cents. If he had 20 cents, how much has he left? So Tom spent 5 cents and 15 cents. So he went to the shop and he spent that. He had 20 cents to give over. How much does he have left? Does he get any money back? 0. He has $0 left because he would have used it all, because 5 and 15 equals 20. All right, number 3. How many halves in 3 wholes? Okay, so I know that if I have 3 holes, each hole, a hole being a whole, one hole, a whole is actually half is half of that. So that'll be have 1 half, 2 halves. So there are 2 halves in 1 hole. So if I have 3 holes, I have 1, 2, 3, 4, 5, 6. I have 6 halves. So the question is, how many halves in 3 holes? And the answer is 6. I can also do that because it says halves. So I can also go 3 times 2 because I know there's 2 halves in 1 hole. All right, we've got a bit of a pattern here. So we go 78 to 81. How many am I adding on? I'm adding 3. And then from 81 to 84, I'm adding 3. So that looks like our pattern. Very good. So I'm now going to add 3. So I'm going to get 87, and then I'm going to get 90. Very good. 3 cakes cost $12. So altogether, the 3 cakes cost $12. How much did each cake cost? Okay, so this one is division. So 12 divided by 3. I need to split the 12 up into 3 parts, okay? And that actually, if I don't know what this one is, if I 3 times what equals 12, you might know that. Okay, and that answer, 3 times 4 equals 12, we know that. So 4 is our answer, okay? $4. Each of the cakes cost $4. Very good. Number 6, 3 boys shared $60. How much did each boy get? So this is division again. So we've got $60 divided by 3, because the boys are dividing it. All right, and I know that 3 times something equals 60. 3 times something equals 60. 3 times 20. Yeah, so if I go 20, 20, 20. 20 plus 20 plus 20. So I'm adding them 3 times. Gives me 60. So our answer is, how much did each boy get? Remember, we've got to put the dollar sign if that's what the question says. That's what they're asking for. How much did each boy get? Each boy got $20. Very good. Is a cube a 3D shape? Is a cube? Cube, yes it is. Because it is made up of the 6 2D squares. Very good. How many 10-cent coins in $2.30? How many 10-cent coins? How could we figure this one out? That's right. So the way I would figure this one out is that we know that in each dollar, how many 10-cent coins do we have? Right, so we have 10 in each dollar. So I have 10 in the first one, then I have 10 in the next one. That would make us $2, and then I've got 30, which would be an extra 3. Okay, so that means that our answer is 23, because we've got the 10, then the 10, then the 3. Okay, so 23 is our answer. Another way we could do that is just by just moving decimal point to that middle part. So then you have 23, but let's just leave that one. Okay, number 9. What is the value of 7 in 7,323? That's right, it is 1,000. The value is, now remember when it says value, it doesn't say what column is it in, or it says what is the value. So when it says value, we want to say 7,000. Okay, so what is the value of the 7? The value is 7,000. Very good. Number 10, round 2,354 to the nearest 1,000. Okay, so this is the 1,000 number. We look at the next number there, which is the 3. Now, does 3 go up or down? That's right, 3 goes down. Okay, so we know that it goes down. Now, we need to look at our two options. What are our 2,000s numbers next to this number? So we've got on this side, we've got the 2,000, and on this side, we've got the 3,000. Okay, so which one? That's our choice. Is it going to go to 2,000 or 3,000? And that's when we look at the 3, the number next to the 1,000 number, and that one goes down because the 3, 1, 2, 3, and 4 go down. 5, 6, 7, 8, 9 go up. So it's going to go down. So it's going to take us to 2,000. So the answer there is 2,000. Very good. How many centimeters in 3 meters? Okay, so how many centimeters are there in a meter? That's what I need to know. How many? 100. That's right. So there's 100 in each meter. And there's 3 meters, so I'm going to times it by 3. Very good. So the answer is 300. Awesome. 300 centimeters. Okay, if eggs cost $1.20 a dozen, how much for half a dozen? Okay, so a dozen is that. Half a dozen, so it's going to be half of that. So what's half of $1.20? Yeah, so a quick way I'd look is like, you can think 120 if you want, like get rid of the decimal point if that helps you. So it's half of 120 divided by 2. Yeah, so that's 60. And just put the dot back there, okay? 60 cents. So 60 cents for half a dozen. Very good. They're very cheap eggs. Okay, let's have a look. What is a quarter of 48 lollies? What is a quarter of 48 lollies? So you're actually going to divide it by 4. Okay, so you're going to get 48 and you're going to divide it by 4. 48 divided by 4 equals what? Now this is when your times table is very important. I know this because I know that 4 times 12 is 48. So my answer is 12. 12 is 1/4 of 48. Very good. Write even numbers between 231 and 239. So just the even numbers. Okay. 232. 234, okay, because they always end in the 2s, the 4s, and the 6. So I'm going to put that one there as well. Also ends in 8. There you go. Very good. So we've got that one, that one, that one, and that one. And there's also, which this number isn't between 231 and 239, but whenever a number ends with 2, 4, 6, 8, or 0, okay, that will mean that it is an even number. Okay, let's have a look down here. Put a cross on all the objects made from 12 cubes. Okay, let's have a look here. Here. This is 1 cube, 2 cubes, 3 cubes, 4 cubes, 5 cubes, 6 cubes. Now, this is actually the same cube, so we can't count that again. This is the same cube, okay? But it's actually got another row just behind it, okay? So that's the same cube. So there's 6 there. I'm going to have a look at the back row. This is another cube there, another cube there, another cube there, another cube there. But we need to remember that there's actually, if I was to turn it around, we'd actually see a cube just behind this cube and just behind this cube. So we can't forget those cubes. So what I usually do when it looks like this, it looks like there will be cubes there, I'm going to just go 6, and then I'm going to add another 6, because this is one row here and it looks like there's 2 of those rows because there's another row there. So we've got one row here, one row there. So I'm going to go 6 plus 6. So 6 from this one and 6 from this row, and that gives us 12. Oh, fabulous. That's 1. So put a cross on all the objects made of 12 cubes. I'll put a cross on that one. Okay, let's have a look at this one. 1, 2, 3. Oh, if I just count it, it will give us 12. Or I could have gone 4 times 3 equals 12. So that one's got 12 as well. Let's have a look here. 1, 2, 3, 4, 5, 6, 7, 8. Okay, so there's 8 in that first row, and I can see that there's another row which looks even, like it's exactly the same as the first row. So that probably has 8 too, which gives us 16, which means we don't cross that one. Now this one, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Oh, fabulous. It's only got one row, so that's good. It's got 12. This one, let's have a look. 1, 2, 3, 4. Okay, so this row has 4. And there is another row here, which would probably have 4 as well, because it looks very similar to the first row. So that's got 8, so that's not 1, so we don't cross that one. And this one, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Oh, too many there, so we don't do anything about that. All right. Okay, so that is your maths marked for this week. I hope you guys did really well. If you have any specific questions or queries or something you're confused about, just let us know, okay? It is important that we know if you are confused about something, and we can talk you through what you're confused about. But all the best, and make sure if you didn't get it done this week that you complete it. Now,